Okay, so what is bonding? So we'll start with some definitions. Unfortunately, this first chapter has a ton of definition stuff. Most of this should be a review for you from general chemistry, although again, depends on how long it's been since you've taken general chemistry, how much of it is recent review or if it's long-term review. The joining of atoms in a stable arrangement always leads to lower energy. And that gives way to one of what things that I would call my class mantras, and that is that anytime I say why in class, you can just about always answer lower energy. Because that's typically why things happen in chemistry. And in particular in organic chemistry, that's true. So just about anytime you say why do things happen? Lower energy. So why does bonding happen at all? Lower energy. Now the unfortunate part is that the next question I will usually ask you is, why is it lower energy? And that may not always be as simple to answer. So there are a few explanations for why, but one of the explanations is that through bonding, atoms can attain a complete valence shell of electrons. And while that's not exactly why bonding is lower energy, it does explain some of what atoms like to do. That also leads to the Octet Rule. And that is that for most main group elements, form molecules that allow them to have a filled octet or a filled valence shell. In general chemistry, you learned about the different types of bonding. You talked about metallic bonding, which we won't really talk about at all in this course. You talked about ionic bonds. Ionic bonds where there's transfer of electrons from one atom to another. And we'll contrast that with covalent bonds, which most of organic chemistry deals with covalent bonds. And in covalent bonds, there's sharing of electrons between atoms. So if we'll look at these two types a little bit, we'll start with ionic bonds and ionic bonding. Ionic bonds are extremely strong. And there are electrostatic interactions between cations and anions. In an example, you might have lithium reacting with fluoride. So lithium has one electron, and it can give up that one electron. And fluoride has 7 electrons, which can gain 1 electron to make fluoride minus. The lithium gave up 1 electron to make lithium plus, and the two can react to make lithium fluoride. While we will see some molecules that are ionic at times in the class, the majority of organic chemistry is going to be related to covalent bonding. In covalent bonding, we have a 2-electron bond shared between 2 atoms. We can put more electrons in for multiple bonds. We'll talk about those a little bit later. So if I look at how many bonds things make, we can look back at the periodic table, but hydrogen makes 1 bond because it only has 1 electron. That's all it has that can react. Everything else, if you look at in the second row, all want an octet somehow, which means that they have 8 valence electrons and they want to fill that. So the way that we usually look at it is if they have 3 electrons or less, they make the same number of bonds, as they have electrons. If they have 4 electrons or more, they make enough bonds to make it an octet. If I want to look at examples of that, I can take boron. Boron has 3 electrons in its valence shell, so it makes 3 bonds. Carbon has 4 electrons in the valence shell. It makes 4 bonds. Nitrogen has 5 electrons in its valence shell. Now, it's more than 4, so it needs enough to get 8. Pause the video for a second and see if you can figure out how many bonds nitrogen should make then. Alright, did you guess that it makes 3 bonds? Nitrogen makes 3, because with its 5 electrons it has already, that will equal 8. 5 plus 3, 3 new bonds. Then oxygen has 6 electrons, so it makes 2 bonds. And then fluorine has 7 electrons, and you can guess what that one is. Right, it makes 1 bond.